So the topic for our presentation is called code mixing. So code mixing basically means taking a sentence that is written in two or more languages and converting it in a single language. It is one of the biggest challenges in NLP because generally when speaking, it is very normal for people to speak in multiple languages simultaneously. Whether it is talking to a doctor or attending an online lecture, it is very rare for people to speak everything in a single language. The problem with this is that it is understandable to us humans, but when it comes to AI, most of the AI models are trained to work upon a single language. When we perform some NLP task on such sentences, the result is very bad regardless of how good the AI tool is. For example, if you are performing video summarization for some online lecture and half of the lecture was in Hindi, no matter how accurate the meeting summarizer is, it will give a terrible output because the input is not understood by the AI model. This is a big problem for every AI tool out there, including ChatGPT and Gemini. Normal translation does not work on such sentences because there are multiple languages involved and every language has a different set of rules and grammar. There is still work going on in this area, and a lot of research is being done day by day on how to address this issue. We have worked upon fixing this problem by working on Hindi English code mix sentences. So our goal is to take sentences that contains both Hindi and English words and to convert them into pure English words while retaining as much information from the original sentence as possible. So this is the Python code for doing that. So first of all, we break the sentence into smaller sentences, and that is done based on the punctuations. So when we encounter a full stop or comma, we break the sentence and we work upon the specific part of the sentence. And the first step in this entire process is to do pre-processing for the words. So for example, let's say this is the function that does pre-processing. So here we normalize every word. So let's say there are multiple words like bahut, bahut, and bahut. There are multiple spelling for the same word. So our goal in normalization is to convert all of the versions of the same word into a single word. So all of this bahut, bahut, and bahut will be converted into single word that is bahut. So next we work upon translating each and every word. So we take every token or every word and we translate the word based on the dictionary. So right here we have a small dictionary. The original code will have a lot bigger dictionary, but for the sake of demonstration, we are using a small dictionary. So for example, acha in English is good, take is okay, ha is yes, nahi is no, and so on. In some cases, for example, in sona, there can be multiple meanings. So for example, sleep and gold, both are meanings of sona in English. So in case if we encounter such words, we are going to use this function called as disambiguate. So this function takes the surrounding words as context and chooses a meaning based on that. So for example, the sona in this sentence can mean sleeping because the word tired is here. I am feeling tired and मुझे सोना है. Sona means sleeping because the word tired occurs here. In this case, मुझे सोना चाहिए but it is too expensive. Because the expensive word is occurring here, the sona here might mean gold and that will be the meaning that will be used. So this is the code for doing that. We are using WordNet for that. So WordNet is like a dictionary and that uses the context of the surrounding words to calculate the most precise translation. The next part is fixing grammar. So this is the function for that. So up until this month, we'll get a rough translation, which is going to make sense to a lot of humans, but it is not going to make sense to computers, and like that is not grammatically correct. So this function works on fixing a grammar. So let's say if the sentence is like, I very hungry am. That makes sense to a lot of us. It makes sense to humans, but it doesn't really mean that it is grammatically correct. So this function rearranges the word and fixes the grammar. The last part is to form the entire sentences. So like in the first step, we broke the sentence into smaller parts. So in the last step, we'll join all the smaller parts which we've just processed right now. Also, one more thing that we're doing before pre-processing is that we're considering the names of the people. So in case of names like Pooja, we should not translate them into something like worship in English. So to work on that issue, we're using Spacey. So this is the part of the code that deals with that. We are using this NER model. And if we get a name, we skip the translation. So like we don't translate the name. So Puja will remain Puja. It will not be translated to worship. And yeah, that's the entire project. Now let's see how it works in real world. So here is a simple sentence. ये वीडियो बहुत funny है, but मुझे सोना है because I'm tired and want to rest. So here the word sona occurs. So this might be translated to gold, or it might be translated to sleep. And there are some English words here. There are some Hindi words here, and there are some punctuations here. So let's fix this. So this is the output. There are five sentences here. The first might be the most accurate one. The last sentence might be the least accurate one. And there are five different versions of the same sentences. So ये वीडियो बहुत funny है, but मुझे सोना है because I'm tired and want to rest. This video is very funny, but I sleep because I'm tired and want to rest. Although this video is entertaining, I sleep because I'm tired and want to rest. So our goal was to retain as much information as possible, and for doing that, we are using five different versions of the sentences, and that's basically how the code mixing works. Thank you for watching.